formula A is equal to the length times width, which you can simply write in L times W. Length times the length times the width, L times W, or simply LW. Let's have a triangle or triangular shape. What is the formula for its area? Okay, this triangular has base and the height h, the base B and the height h. How do you get area? Area A is given by a half into bracket base times height, or simply a half times B times h. Okay, or a half times B times h, or a half B h, where B is the length of the base and h is the height of the triangle from the base to the peak here. That you know very well. Let's look at another shape, which is a circle. Okay, the circle has radius r, and the formula for that you know very well is pi r squared. Pi r squared, where this value of pi is 22 over 7, or simply 3.142. Another shape we look at is a trapezium. With this length B, the upper length A, and the height what? H. What is the formula for its area? And remember, it is a half times, or put in bracket, A plus B, close the bracket, H. A plus B. It means you first add the value of this length plus the value of this length, first add them before you multiply by H and multiply by a half. Now these are the regular surfaces that do have a defined shape, and you can just determine the length of the sides, and use the formula to determine the area of these shapes or these surfaces. How do you get the area of the irregular surface, irregularly shaped surfaces? Now this is simply done by estimation. An estimate of an area of an irregular shape can be done by dividing it into squares, each of area 1 centimeter squared. Now let's look at an example. Estimate the area of the irregular surface shown below. Now if we have this irregular surface here, now we get a graph paper which has squares, and we have said that each square here is 1 centimeter squared. Get a graph paper which has squares, and each square is 1 centimeter squared. Okay, then we are going to count the full squares. Okay, so in our solution we need to get the number of complete squares and we get the number of incomplete squares, and we shall divide the number of incomplete squares by 2, and the number of complete squares we shall add. So if I'm to take you back to this, these are the full squares. So 1 2 3 4 5, 1 2 3 4 5 6. So if I multiply this by this, I get 30. So these are 30. Then I go the other one, 1 2 3 4, that's now 34. 1 2 3 4, 38, and there is one here which makes 39. So there are 39 complete squares. After having counted all the complete squares, then you go to those which are not complete. Say 1 2 3 4 5 6 7 8 9 10 11 12 13 14 15 16 17 18 19 20 21 22 23 24 25